All right, definition of concavity. A function is concave upwards if f prime is increasing. The derivative of f is increasing on the interval. And a function is concave downwards on an interval I if f prime is decreasing on I, on the interval I. So if it's decreasing, it's concave down. If it's increasing, it's concave up. And what we're talking about here is the derivative itself. Now, to give you a visual about concavity, right here, we're concave down. And right here, we're concave up. If this is f of x, now, can you tell by looking at this and knowing the definition that the definition holds true? Or does the definition not make any sense?
The definition doesn't make any sense.
That's a no.
Well, look, it says...
Well, look, okay,
It says f prime is increasing on the interval, so it's concave upward. But that one's increasing and then it's concave downward.
So you're saying this part right here is increasing?
Yeah.
It's not about the increasing, it's about the minimum maximum.
Well, no, the function's increasing here. F is increasing.
But it's caved downwards because the rate goes down.
That's not a very good mathematical argument. That's to help us understand concavity. But take a look at what I just wrote and what the definition is, and tell me if you see if there's any similarities or differences there. Well, it's concave down. It says the function is concave down if the derivative is decreasing.
Derivative is like the tangent line, right? So if you drew a tangent line, the tangent line would still be increasing too. Not necessarily. Yeah, completely necessary.
Well, let's see if Noah's right or if he's stuck his foot in his mouth. All right, so now there's a tangent line. Now I'm going to put another tangent line here. So I'll say that's tangent line 1. There's tangent line 2. Which one has the bigger slope? So T1 is greater than T2, right? So now if I go to the maximum point, which if I actually drew this graph well, would be over here. There's T3. What's T3? If it's at the maximum, T3 is smaller. That's a 0, isn't it? And now we have small negative values getting to even smaller negative values. Until, believe it or not, there's a point right here where it switches. And it starts to increase again. So here's the thing, and you guys made, well, at least Noah did. I'm sure some other people did as well, because some people were saying, yeah, doesn't seem to make a ton of sense. But this happened in third hour too. We mistakenly attributed the function f to the function f of x. So, we attributed f to f prime and said this is f prime as well. And so this is increasing and then decreasing, but it says it's going to be increasing or decreasing on the entire interval, but it's increasing and decreasing here. But the derivative values here, really small or large positive, but they're getting smaller, getting to 0, and then they're going from 0 to very, very small numbers or very largely negative numbers, and then eventually they're going to get smaller again and approach 0, and then they're going to become positive. So here they're increasing until eventually they'll start decreasing again. Now, kind of in the middle between a maximum and a minimum are what we call points of inflection. And that's points where concavity changes. Concavity is equal to 0 in this case.
So your critical value.
No, they're not critical values because we're talking about a second derivative. So instead of talking about critical values, we're talking about points of inflections. They are what they are to the second derivative what critical values are to the first derivative. However, they are not critical values. So do not mess them up, because if you do, then you're looking for totally different things. Now, if you're talking about, and this is what I talked about with if you're just talking about f prime, or f and f prime, from here, we can figure out if f is increasing or decreasing. Critical values, that's where f prime is equal to 0. And extrema. And that's between analyzing the function and its first derivative. Now, if we dig a little bit deeper and we go down to the second derivative, what we'll get is f prime is increasing and decreasing. You get points of inflection where f prime or f double prime is equal to 0. And then we could talk about concave up and concave down. So those are the two big things that we have going on here. If it's concave up, f prime is increasing. If it's concave down, f prime is decreasing. So the same rules apply to figure out if we're increasing or decreasing. We're going to still end up using a sign test. And we're either going to use them on critical values to figure out extrema, points of inflection to figure out concavity. this also figures out if f is increasing, decreasing, and this figures out if f prime is increasing, decreasing. So basically that's not necessarily the second derivative test because that's totally something different.
So is this still part of the first derivative test?
No, it's not part of the first derivative test. It's just
And what would we write when we have to answer it?
well, we have to do a problem first.
No, but I mean like, you know like how we wrote by the first derivative? F increasing slash decreasing.
All right.
Concavity.
All right. So now, let's take a look at an example of this. And we're going to start. You'll get this if you want it. If anybody wants it, they could take a look at it. Now, I'm going to start with a basic example. F prime of x is equal, or f of x is equal to x squared plus 2x plus 3. Now, what type of graph is this? Parabola. Does it open up or down? Opens up. So it opens up, which means what can you say about concavity? No. It's concave upwards. It's concave upwards. When you're talking about concavity, your only choices are concave up or concave down, not concave increasing or concave decreasing.
Yeah, but why were people saying that?
Well, I'm correcting them. Now, in order to figure this out, take f prime of x. We need that first. Do you believe it's x2 plus 2? Or yeah, 2x plus 2. And I need f double prime of x, which is 2. Now, this is greater than 0. Now, if
Wait, what is that?
Is it 4?
4,
What does that mean though?
it's positive for the entire real number set. This represents the entire set of real numbers. Now, since it's positive, if f double prime is greater than 0, what do we know about concavity? Is it up or down? Up.
I don't get why. Why if it's greater than 0?
If it's greater than 0, so if f double prime is greater than 0, it tells us that f prime is increasing on the interval negative infinity to infinity. And since f prime is increasing on negative infinity to infinity, we can assume, or not we can assume, we can conclude that f prime of x is concave upwards on negative infinity to infinity. Because this is right here.
So are there no points of inflection?
Inflection. No points of inflection because there's no x value. We just know it's positive for the whole thing.
So that was like really easy.
Yeah, well, that's just the basic one. Now, does it make sense looking at the picture that it's concave up for the entire function?
Yeah.
Yeah. All right, now let's take a look at a different one.
Wait, what's after f of x is something?
Concave